Thank you for the invite. I'd like to thank the organizers for the invite. And today I am going to begin my talk with a disclosure. I don't know what just happened. I can't see anything here.
Piyali, hold on just 1 minute. He's fixing it up here. And try to speak into the microphone.
Okay, there we go.
Yes.
Yeah, I'd like to begin my talk with a disclosure. So the views which are presented here are those of the authors and not of the Department of VA or the United States government. Now, a brief background. So as we all know that hospital surfaces are contaminated, often contaminated with HI-causing organisms such as the MRSA, Acinetobacter, C. diff, etc. And that can act as a reservoir for transmission of pathogens to hospitalized patients. Now, this can occur via the direct contact or via the indirect contact through the hands of the healthcare workers. Now, in order to prevent such a transmission, hospitals have put forward some of the policies by which they actually do cleaning and disinfection. And based on those policies, some of the common cleaners and disinfectants that are used within the hospital include isopropyl alcohol, 70% isopropyl alcohol, and some of the disinfectants include the hydrogen peroxide, the quart ammonium, and the mixture of isopropyl alcohol, as well as sodium hypochlorite, more commonly known as bleach. And the wait times for each of these chemicals vary from 1 minute to about 4 minutes. Now, despite taking all these, actions, we know that about 30 to 50% of the hospital surface remain contaminated. Now, some of the hospitals have actually implemented using additional disinfection strategies, including the one that is shown here. This is using a no-touch UVC robot, and this is used to clean the room following patient discharge. Now, as you can see, there are main drawbacks for this. One, it could be only used when the patients are not in the room, and also it can probably not disinfect all the surfaces equally at the same time, just because it can, disinfect the tray table, the top of the tray table, but the bottom of the tray table, the UV won't be able to reach. So we were looking for options where we know that the patient room is contaminated and the surfaces surrounding the patient room are contaminated, but we were looking for options where we can find a portable device, so as we can take it to anywhere outside the patient rooms, and we would be able to use such adjunct technology such as the UVC safely around the patient areas. So, and our prayers were answered. And so we found this handheld device, which uses the filtered Far-UVC. And as you can see, this device has a start-stop button at the side, as shown here, and a UV emanating surface at the bottom. And if the intended operating distance is reached, you see a green light. However, if the intended operating distance is not reached, you see a red light. And the distance that it is set at is about 1 inch. So now we wanted to ask, okay, is this device good enough and will it be able to reduce microbial bioburden in a healthcare setting and just like the, germicidal sodium hypochlorite disinfectant wipe? Now, we did a within subject surface design, and I'll come to this design in the next slide. And we chose 5 different high-touch surfaces, both within the patient room and outside the patient room. As you can see, some of them are hard surfaces, such as the bed rolls and the keyboards for the nurse's station, tables, workstation on wheels. However, we purposefully chose like a soft surface, such as the mannequins too, just to see the difference in the efficacy of the device. Now, this is the workflow for the experiments. And what we found is like we chose the bed rail here, and there are like 2 different arms to this study. One is the UV and the other is the sodium hypochlorite. So within the UV arm, as you can see, there's a pre, which is no treatment of UV, and a post UV, and we collected samples from both those. And the UV was used only for 30 seconds. And for the sodium hypochlorite, as you can see, we had a similar scheme where we had, no treatment and treatment. And this was for 4 minutes following the, the same protocol that they use in the hospital. So now we took those plates, incubated them overnight, and then, once the colonies grew, we counted all those colonies, and some of these colonies were morphologically different than the others. We took the ones which were morphologically different and then subcultured them onto the blood agar plate, re-incubated them for overnight, and then subsequently identified them using MALDI. Now, what we found was like when we had no treatment for both the sodium hypochlorite, which is shown here in red, as well as the UV, we found that the mean colony counts hovered around like 20 or so. However, when we did the treatment for both arms, you see like a substantial decrease in the mean colony counts. And so when we converted them into percentages, we found that the sodium hypochlorite was about 99% effective. However, that of the UV was about 82% effective. So we concluded that this was effectively reducing the bioburden on the surfaces. Now, we wanted to see what type of microbial, microorganisms did we recover from these surfaces. So first, we wanted to look at some of the gram-positive organisms that were recovered from these pre-cleaned surfaces. And they mostly belonged to 4 different genera, as you can see. So they were Bacillus, Enterococcus, and Staphylococcus, as well as Streptococcus. And we then wanted to look at the gram-negative ones, and you can see that there is more variety among the gram-negative ones. We recovered Acinetobacter, Citrobacter, Enterobacter, E. coli, Kleb, as well as Pseudomonas. And so we wanted to see what is the distribution of these gram-positive versus the gram-negative bacteria within each of these surfaces. And what we found is that for all of these surfaces, we recovered more of the more of the gram-positive versus the gram-negative. And in case of S. aureus, we further identified if those, Staphylococcus aureus was MRSA. And we did find in some instances that some of the Staphylococcus aureus were MRSA indeed. And those were found mainly in the keyboards and the workstation on wheels. Now, when we looked at the data with the mannequins, we recovered most of the bacteria from the mannequins. And this is what we expected because this is a soft surface. And we thought that we will recover more from a soft surface, which retains more of the organisms, than some of the hard surfaces. So in summary, our study actually provides evidence that this device is effective in reducing the microbial burden on a variety of possible surfaces. And we saw that the reduction was substantial, about like more than 80% in case of the FFUV versus 99% for the sodium hypochlorite. And some of the organisms that we found in the pre-treated surfaces included some HAI-causing pathogens. And finally, as we all know, that some of these chemicals corrode some of the equipment. So we think FFUV will be a good alternative in that case. And finally, the three takeaways from the talk today is that this device can effectively reduce the bioburden on different types of surfaces. And this can be used on some sensitive medical equipment where you cannot use, sodium hypochlorite. And last but the least, this device may provide a safer alternative for the workers and the environmental, for the healthcare workers as well as the environmental services personnel. And with that, I'd like to thank Freestyle Partners and FSP Innovations for their generous support for us to be able to do this study. And this was done with a cooperative agreement through the VA. And I'd like to thank members of our study team, including Tanuri and Brandon, who did most of the work. And John David is the one who did the statistical analysis. And I'm also thankful to Dr. Janavata and Dr. Maher for mentoring me. And with that, I'd like to thank everybody for your attention. And I'd be happy to take any questions that you may have.
Yeah. We have time for maybe one or two questions. Is there? Yeah.
Thank you for a nice study. I just wondered whether you'd thought about any measures of whether there's any significant soiling on surfaces, because I guess that the UV will work less effectively where the
You touched upon a very good point, and I have done some previous work in vitro, and I have shown in those cases that if you add without the soil load versus the soil load, there's a huge difference. And I think we discussed yesterday more about Canada, and I did a study on Candida auris, where we have seen that without the soil load, the log reduction was much more. This was more of a real world study, so we didn't do, we assumed because we were looking at the hospital surfaces that they would be more contaminated with other soil loads such as serum and other stuff from human. Yeah.
All right, one last question here in the front.
Deb Mosca with Exmer. Thank you for that presentation. I was just curious if you analyze the cost for using the UV to disinfect an entire band rail with a small head and 30 seconds per application versus a swipe with the germicidal solution, which you just wait.
I know. I hear you because, we have another study, which is part of this study, and I haven't gotten into that. So this is like a feedback from the nursing staff. And we found that, the nursing staff, they are so used to the cleaning and disinfection schedule and, just finding the right, wipes, because all these wipes are different for different types of equipment and surfaces, right? So they think that this is like sort of a challenge for them. They were very open to using the UV, although they did mention that, for a longer surface, it would take a little longer time for them. And so we have another another part for this study, as I said, but, you know, they are open to using this. They said that they would do anything that can help the patients and reduce ATI.
All right, thank you very much.